Let's go over the basic idea of how to solve a system with 3 variables. In general, we're going to take 2 equations, eliminate a variable, pick 2 other equations, and eliminate the same variable if possible. So let's say we concentrate on z, and we eliminate z. Then, if I take these 2 equations and I eliminate z, I get something with x and y. If I take these 2 equations and eliminate z, I get another x and y equation, and then I'm going to do elimination a 3rd time to figure out, okay, what is x or what is y? That's the general idea. Doing elimination 3 times. Over to the right here, I'm going to actually write the ending piece whenever I eliminate z. So x plus 2x, I get 3x. 3y plus y, I get 4y. The z's eliminate, and I'm left with equal to -10. That's only 1 elimination. I got to do 2 eliminations. So now I'm going to pick 2 others. So I could pick these 2, but I have to eliminate the same variable. If I chose to eliminate z first, I'm going to eliminate z again. So in order to eliminate the top, or I say top, this equation will have to be multiplied by -3. I'm going to write the ending piece down here. So we get this is the equation after you distribute a -3 all the way through. And then the second equation I'm just going to copy down. And I'm ready to eliminate z. I eliminated once, eliminated twice, and now I've got 2 equations with just x and y's. So I'm going to now use these 2 to figure out what x and y are. So I'm going to eliminate a 3rd time. I'm going to rewrite this equation up here so I can see, okay, now this is my 3rd elimination. So setting up the 3rd elimination, I'm going to multiply this 2nd equation by 3. So we're ready to eliminate the x's. We realize what y is, -4, and typically I would say go back to the original, plug it in, get 2 new equations. You could also use maybe these equations if you trust your work. Those of you good at elimination, use these equations. Otherwise, you're going to have to go back up to the original and get y's and z's together and eliminate a 4th time. I'm going to try to stay away from eliminating a 4th time. I'm going to plug -4 into this equation and see what x is going to be. We'll solve for x. So I could choose the first equation, plug in x, plug in y here, solve for z. I could choose the second equation, plug in x, plug in y, solve for z. Or the third. It should always work. No matter which one I pick, I should always be able to find z. I'm going to choose the first one. Plug in an x. Those of you who haven't done it yet, plug in x. You plug in y. Solving for z. Showing every step, not necessary. So here's where my ending answer comes into play. We need an ordered triple. Since I have 3 variables, I'm going to put it up as a point. X goes first, Y, then Z. It's always alphabetical order. So the X coordinate was 2, the Y coordinate was -4, and Z was the 1. This point should satisfy every single one of these equations. And just to check, 2 times the X coordinate 2 is 4, plus -4, plus the Y coordinate Z, plus the Z coordinate 1, it does equal 1, it checks. So, I'm going to start with the second 2, eliminate X's. Eliminate X. Z and 8Z. -4 and 1. I need to pick 2 other equations to eliminate X. I just can't pick the same 2. So just because it's visually okay for me to do the top 2, I'm going to eliminate X here, but I got to figure out, wait a second, one of them are going to have to be multiplied. Suggestion was, why can't we just take the top and the bottom? And I'm going to, because all I have to do is multiply by a 2 here instead of a -2. So I'm going to do that. Multiplying a 2 with this last equation, top equation same stays. The second equation, distributing that 2. Eliminating the X's. Hopefully you've already gone forward with that. So this was supposed to be a 2. So now I'm left with -1 here. So we're going to take this bottom equation, mix it with the previous equation, and eliminate a third time. You got to determine what you want to eliminate by. I'm going to suggest the y's, because all I would have to do is multiply by a -3. So that way -9y with a +9y would cancel out. The adjusted second, and I'm ready to eliminate. So if we divide both sides by -60, we get a z coordinate of 0. So using this equation, I'm going to plug in my z coordinate of 0 and see what y is going to be. So I'm using that equation, plugging in 0 for my z, solving for y. And if you divide by -9, we get y being a third. Because I have single x's in these two, I'm actually going to use this second equation to plug in 0 into my z, a third into my y, and figure out what x is. Last step is figuring out your last coordinate. We get x -2 plus nothing, so this really just turns into x -2 equals -4. Looks like we're getting -2 for our x coordinate. So our answer is an ordered triple. -2 is our x coordinate, a third is our y coordinate, and 0 is our z coordinate. So -x plus 2y plus z equals 3. 2x plus 2y plus z equals 5. 4x plus 4y equals, or plus 2z equals 6. So I'm going to take these two and try to eliminate the y's, but in order to do that, I have to negate something. So I'm going to go through and change all of these signs. When that happens, now let's combine. I get -x with a -2x. 2y minus 2y, that goes away. Z minus z, that goes away. So I'm left with -3x equal to -2. So sometimes we can actually immediately solve for a variable. X is supposed to be 2/3. If our purpose was to eliminate the y's here, I'm going to try the last two to again eliminate the y's. But in order to do that, I need this to be a 4. So if I multiplied by a 2 through, keeping the negative signs, this is my result. I'm going to use that last equation, 4x plus 4y plus 2z equals 6. So they all go away, and I'm left with nothing on one side, but I'm left with negative 4 on the other side. I'm left with a statement that is not true. This is showing a no solution in this problem. So the answer to this, no solution. In your homework problems, you will have 2 problems that come out nice. It's not the last problem, but one of the problems do not turn out, well, we didn't have to do a lot of work, so maybe we could consider this nice. But one of them will be a no solution. Homework problems 26 through 28 on page 182.